Up on the top here are our different tools that we have options for, like preparation, join. They're all bucketed together essentially. Off to the side on the left here is our configuration pane. So again, we can do some different things to configure our workflow or just the tools inside of it once they're on the canvas. This white space here is the canvas, and then on the bottom is our results pane. You can look at the metadata behind each column of your data and see what it's already sized at or what the data type is. If we go back to data, you can see what had happened before and then what happened after we put the tool on the canvas. So a few different things that we can use to see how our data is being changed. Again, we're going to go through how we brought in our data behind our stores. Essentially what we did is we went out to our store locations on the site and we pulled information that we needed to make a web scrape. Through this process, we were able to get locations, addresses, and some other details that we were looking for. We were hoping this would be publicly available data, but it actually wasn't, which is why we went out to the sites and essentially created a scrape of the data. We went to stores like Walmart, Rite Aid, and CVS, and we scraped that information. These workflows on their own could be an Alteryx webinar, so we don't really cover it today. So you won't really see that process. We're just going to see what had happened from it. So we took the files and we separated them all into different states and put it on the same folder on my C drive. We can see that by clicking down the caret, looking at the file, and you can see we have all the different states separated. These all contain my different store data. So the little hack that we're going to do is rather than selecting a distinct file, we're going to type an asterisk and then the CSV, which we can see on the configuration pane or just in this file name right here. So what that does is it pulls in every single file that is in that folder. And we can see that in the results pane on the bottom. So you see Alabama there. If we scroll down, you can see Wyoming, Texas. You see the whole list in the state name. Then we want to filter out just for the Gulf states. So we do state is in Mississippi, Texas, Florida, Alabama, Louisiana. Those are our states we're concerned with. You can see that we sort of use SQL syntax here. There's so many other ways that you can type it out as well. We have this information now. We have the location, but we don't have a longitude and latitude, which is why we're going to use our street geocoder. This uses the information that we already have to then assign a spatial object that we can work with later down in our workflow. And just for ease of understanding and looking at our data, we then place a select tool to rename it as the store spatial object. That way we don't get confused with the port spatial object later. So now we can visualize this in Tableau. So our first visual here, we can see all of our stores on a beautiful map. What we can do with this is essentially tell if there's a lot of stores in one area, maybe we should just put a supply house there, so that way we can avoid shipping via ports altogether.
Cool. Now that we have the store location, let's go after the port information. So this data is publicly available through the U.S. Department of Transportation. Side note, data.gov is a fantastic source for data in API or spreadsheet form. An API stands for Application Programming Interface, and so you can see the text input tool connected to the download tool here. All I need to do is give the API endpoint, the URL, and my free credentials. The text input tool holds the URL, and the download tool pings the DOT website for the data that we need. The combination gives me a bunch of messy JSON data. Then I'm selecting the download data that I want to move on with. Sometimes fields are not relevant for the rest of the analysis, and sometimes they have a wacky name. I can remove the fields that I don't want and change the names to ones that I do. Also, I can easily change the data type of any field using the select tool. I use this tool a lot, and by a lot I mean almost every 3 tools. It's a good way to keep your workflow focused, making tiny tweaks to sort of keep the ship sailing in the right direction. So next tool I'm going to use is a pretty cool tool. It's called the Json Parse tool. And this tool is amazing. It does the work of 200+ lines of code and returns the name and value pairs, as you can see in my data preview. So here's the input, and here's the output. Pretty cool. The text to columns tool is next. What I'm doing is parsing the data based on a period with this tool. And by specifying the delimiter, I can split the JSON data into separate columns with just one step. The tool is setting up the column names that we will be using later in our analysis. All right, the next thing we're going to want to do is clean up the data a little bit more. There are some fields that we know we're not going to use, so we're going to use a filter tool to take those out. And then, once again, we're going back to our favorite tool, the select tool, to trim some of the fat. I can remove the fields by simply unchecking a box, and if I want that field later, I can recheck that box. You can see the fields that I'm renaming highlighted in this reddish hue. I'm calling out the ID, the name, and the value, which will make it easy for anyone to follow my workflow. Now, as you can tell from the data preview, our data is extremely narrow, but I want it to be wider, so I'm going to use the crosshair tool to reorganize the data in my table. And the name is my column header, and the value is, you guessed it, the value for the column. I also specified that the data be grouped on the ID field. So from the output of the crosstab, you can see that we now have more fields that won't necessarily be useful for the rest of our analysis. So I've added another select tool to keep my workflow focused, moving on with only the ID, latitude, longitude, and port name. Now that my data is pivoted, and I only feel that I need to create points tool, Alteryx literally comes from AlterYX, and our create points tool can turn latitude and longitude values into centroid spatial objects, similar to what Chrystal did with the stores. Now that we have those points, we can use the TomTom dataset to get a geographic name of the place in which that spatial object is located. This is the reverse geocode tool. It's kind of doing the opposite of what Chrystal did with the geocode tool, and it's giving the spatial objects a geographic name and place. In the configurations pane, under options, I can select the level of detail that I want to reverse geocode. So right now, we're only going after country subdivision. Again, we have a select tool, changing the name of the field that we got from the previous stat, so we're changing it to state. And then we are going to use one more filter tool because we only focus on the Gulf states in this scenario. It's the region that our hypothetical logistics team manages. Then, before we join the data together, we are going to do one last step. We're going to use the trade area tool to draw polygons using the TomTom dataset based on a 60-minute drive time. Essentially what we're doing here is drawing a border around the points within 60 minutes of a port. Every point, aka store, I can drive to within 60 minutes. In the configurations pane to the left, you can see that we're working with the centroid that we created a few steps ago. We can set our units as drive time and select the TomTom dataset before setting 60 as our specific value. So why are we only concerned with stores 60 minutes from the ports? Well, in our scenario, most shipments go to a regional distribution center before they are distributed to the stores. But if a store is close enough to a port, it makes more sense just to ship a little stock straight there. So I'm going to open up the Tableau workbook to show our progress. And here you can see those ports with their drive time polygon on map. They have odd shapes because, like we just specified, they're based on drive time and not a standard radius.
That's awesome. Now that we have those port areas where vessels can't dock, and we have those exact store locations, we want to see this information in the same view. So how we're going to do that is we will want to utilize those spatial objects from both the ports and the stores that me and Jake had created. What we're going to do is we're going to use that spatial match tool, which is essentially like a spatial join, to then match the stores to the ports. So what we want to do is select the store as the target, and the ports are our universe, or input. And what it'll do is it'll map the store, which is a distinct area, into that port trade area. So this is just like the select tool where we can then change the name, change the type, and change the size. It's great. Jake will utilize the output of this join a little bit later when we pull in our weather data.
Yeah, but before we do that, let's check it out in Tableau. So here you can see the ports, and when I hover over, you can see the corresponding stores. This information is possible because of the spatial match tool that Chrystal just used. And then if I wanted to, I could select a port like Miami and filter in and see all the stores. This is pretty cool, but we need to do some analysis. So let's go after the weather information. For our final stream of data, we're going to be using a custom-built macro to pull data in Alteryx. But before we do that, we should probably talk a little bit more about what macros are.
Yeah, so for those who do not know, macros are really powerful and efficient for organizations to use. You can essentially package a repeatable process, and others can then use it. So we can look at behind the scenes of our macro here, which is just sort of like the face of the workflow. And we can see that it's just a packaged workflow behind the actual tool that you see. We can take a cumbersome process and we can make it easy and repeatable for everyone in the organization. So this macro here is a set of steps that we repeat often at Continuus. So we basically just packaged the workflow into a macro tool, and we then shared it across the organization. That way no one really has to worry about going through these steps ever again.
Cool. Thanks for that clarification. You can see the dark sky macro here. And this is the same information you might see on your iPhone if you have the Dark Sky mobile app. Like Chrystal showed, behind this icon is another workflow of repeatable steps, but luckily, since I'm lazy, it's packaged up for me, and I don't have to do those steps every time I want to pull in this information. All you need to do is pass our port ID, the latitude, and the longitude, and it will return 8 days of weather forecast for all the ports in the Gulf of Mexico. You can see from the data preview, it returns a lot of weather information. We have things like barometric pressure that could help us predict storms if we decided to iterate on this analysis. However, for our example, we're only looking at wind speed, and we are going to use a filter tool to look for wind speeds higher than 10 miles per hour. These will be our affected ports. We can clean up the data with the select tool, since we don't need all of this weather information. But again, if we wanted to iterate on this, we could come back and add something. It's as easy as rechecking a box. Finally, we are going to use the formula tool to reformat the date field. This is a very simple example of the capabilities of the formula tool, which for most people is their best friend in Alteryx. It's like writing a formula in Excel, and it's very useful. So the last step before we export our data is to join our weather data to our location data using the join tool. Here's a pro tip. The join tool lets you do almost everything that the select tool does and the spatial match tool. So if your team decides where they want to keep these steps, such as renaming fields, changing data types, sharing your workflows becomes much easier. At Continuus, we only change things usually in the select tool. So if another engineer needs to change something, they don't have to go hunting for it. Now we have our stores inside our drive time polygons, accompanied by weather information. And as cool as that sounds for me to say that, it'll be even cooler in Tableau. But first, let's walk through exporting the data so we can actually work with it.
So now all of our information is together in sort of like a pivot table-like format, which is great. But we want to have that accessible to everyone in the organization. So what we're going to do is we're going to push it to Tableau server. So really what it does is it takes our source that we just created, and it then posts it to our server using an API call. So the cool thing about this tool is if you put multiple Tableau server outputs, like this one, you can then differentiate the folder that you want to send to. So you would just change the project name for each iteration, and it could go to different folders. That way, every department has access to different extracts based upon their needs. But you can also claim one as the certified source, which is just unfiltered, unaltered, essentially. So for our presentation this entire time, we've been referring to a Tableau server extract, along with just showing our presentation in Tableau server as a whole.
Yeah, so let's take a look. So you can see here, on the right, we have a weather forecast for the next 8 days with this blue line. You can see the affected ports with the gray bar charts. If I hover over a bar chart, I can see the exact port names with the corresponding wind speeds. You can see the ports down here on the left and the stores down here on the right. The darker the port, the higher the wind speed. And if I go back up to the top and I filter on a bar chart, it should change the ports. And if I select the port, I can see the stores. So you can see all the stores that might be potentially affected by delayed shipments, and that could equate to a lot of delayed or lost revenue. So this example was for stores within 60 minutes of a port and for wind speeds greater than 10 miles per hour. But some of you might be thinking, what if another analyst wants to change the drive time or the wind speed? Do you need to send the whole workflow? Everyone has their own version of the workflow, and society as we know it collapses? Not exactly. We can add interface tools in Alteryx, essentially creating a UI for end users to change specific parameters that we can set. It can all be hosted in Alteryx Gallery, where people can access it from anywhere with an internet connection. Chrystal, want to talk more about that?
Of course. Gallery, for those who do not know, is sort of like the Tableau server of Alteryx. The Gallery allows others who do not have a designer license to then utilize Alteryx. For anyone with privacy concerns, where you may not want everyone to see what's going on in finance, there are many different options for different permissions features that can keep groups safe from others' eyes. So really, Gallery is the ultimate sharing ground for workflows and analytic apps that people can access anytime and anywhere. This will save your analysts tons of focus time because Lucy from logistics will no longer have to ask Fran from IT to change the wind speed or drive times in our workflow. Lucy can just perform this task on her own from our gallery using analytic applications. But since I said that sort of buzzword, let's talk about it a little bit. Alteryx has a great section of tools that helps us creating macros and creating our analytic application. These tools are the interface tools. So essentially, Fran can just go out and use the interface tools to change different parameters in her workflow for users like Lucy. So you can see over our workflow here, over the trade area and the filter, we have 2 different analytic applications going on. So one is for the drive time, and the other over the filter is the wind speed. The only thing that we need to do is save this to our gallery. So we go to File, Save As, and then choose your company's gallery, which is just the URL. We can give it any name we'd like, and for this purpose, we're not going to validate. So we can then save it. So we give it a few minutes, and we can now view it in our browser. This takes me directly to our analytics app in our gallery. We can then click Run, which Lucy would end up doing in this example, and she can change her wind speed to whatever she'd like, along with her drive time. What this will do is changes the workflow, and it then gives you an output once we run that analytic app. In this instance, it would change what happens in Tableau server. The other fun feature in Gallery is you can schedule your workflows, or the data flow more so, to run on a reoccurring cadence. So we can choose reoccurring, you can change the frequency and change how often you'd like it to run. So, maybe we don't really care about this daily, maybe we want to see this weekly. You can also change, if you keep it hourly, you can change how often it runs and set it at whatever cadence you want your data to reset. So we can start it at different dates, and we can also end it at different dates. For this instance, we'll just cancel it, but that way you never really have to worry about your company having current data.
Yeah, so that's pretty sweet. The core of the demonstration was to highlight the relationship between Alteryx and Tableau. In our example, Alteryx did a lot of the heavy lifting by combining disparate data sources and applying geospatial context to our data. Tableau did what it does best, displayed complex data in a visually appealing and easy-to-consume format.